All right, so let's take a look at this function. So we have f of x equal negative 6x minus 3 over x. And we want to find the increasing and decreasing interval, find any local max and local mean value, and determine the concavity and point of inflection. So to determine the increasing and decreasing and find any local max and local mean, we can use the first derivative test. So we will first find f prime. Okay, so and then after that, we're gonna set f of prime equals to 0 and find out the critical value. So for x, and then find x where f prime is equal to 0 and f prime is undefined. And then after that, we're gonna done a sign test for f prime. Then we will be able to answer part 1 and part 2. So let's go ahead and find f prime. So my f prime is gonna be, so I will rewrite the fraction at the power function. So I will have negative 6x minus 3x to the power negative 1. Okay, and then the derivative of negative 6, x is negative 6 minus 3. The derivative of x to the power negative 1 is the power rule, right? We will have to bring down the power, the exponent reduced by 1. So I will bring down the power, so it's going to be times negative 1, x to the power negative 2. And then from that, I will rewrite the expression by negative 6 plus 3 over x squared. Okay, and of course, we can solve the equation right now, or you can simplify the fraction, put that in the same denominator, and then solve later. So I'm gonna go ahead and multiply the x squared to the negative 6. So I will have negative 6x squared over x squared plus 3 plus 3 over x squared. So this will give me that f prime of x will equal negative 6x squared plus 3 all over x squared. Okay, so this is my f prime. Now, in order to find f prime equals 0 and f prime undefined, since this is a rational function, the function will be equals to 0 when the numerator equals 0 and undefined when the denominator equals 0. So we simply set f prime, set the numerator equals 0 and the denominator equals 0, and then solve for x. So I have 6x squared equal 3, and then that gives us x squared equal 1/2. Take square root both sides, I will have plus and minus square root of 1/2. Make sure you have plus and minus because you take square root. And on the other hand, I will have x equals 0. Okay, so x equals 0 is the undefined, and that is also the value that not in the domain. We have the x cannot equal to 0 on our function. The domain is x cannot equal to 0. So this value will not be your critical point, but it's okay to put in the number line test. This is just an asymptote, okay? So you will have an asymptote at x equals 0. So now the next step is we're gonna have to do the sign test. So let's put everything together and in the sign test. So I will have negative root 1/2, 0. We know this is the vertical asymptote, and then square root of 1/2. So we're gonna go ahead and pick some test points. So I will pick the point. So since this is negative root of 1/2, I'm gonna take negative 2. Okay, and I want to find out what number between negative root 1/2 and 0. So you can approximate that value in the calculator and see what that approximate. So this is about negative 0.7. So I will pick the value is negative 0.1. And then here I will have 0.1, and the last number I will test will be 2. So after you pick the value that you're gonna test for the sign of each interval, we're gonna take these value and put into our f prime. Okay, so this value we're gonna put in f prime. So we will have to find out what the f prime of negative 2 f prime of negative 0.1, and f prime of 0.1, f prime of 2. Okay, so this can be done in your calculator. So we will have negative 6 times everywhere we see an x squared, we will replace by negative 2. So negative 2 squared plus 3, and then over negative 2 squared. So that will give us a negative number, negative 5.2. And again, this number, we don't care what number is it. We just need to know the sign within that interval. When x equals negative 2, this will give us a negative value. So this is negative. And then between negative root 2 and 0, we will have negative 0.1. So I'm going to go ahead and do 0.1 in there. So we have negative 6 times negative 0.1 square plus 3, and we divide negative 0.1 square. So there's a common mistake that people have, user error is when you have a negative, make sure you put in a parenthesis when you square. Okay, and then you will got the positive 294. So this value is positive. And then we do that for 0.1. We do that for 0.1, 0.1. And that will give you another 294, which is a positive value from that. And then after that, the 2, we're going to replace that by 2. And that gives us negative 5.2. Negative 5.25. So this is the negative value. So again, we don't care what number is it. We just need to know what is the sign of within this interval. So it looks like we have the negative, positive, positive, and negative. This will tell us that between the interval from negative infinity to negative root 1/2, we have a decreasing. And this is increasing, increasing, and decreasing. Okay, so we're ready to answer the question part A. So the function is increasing on the interval between negative root 1/2 to 0 and 0 to root 1/2. And the function will decreasing on the interval is negative infinity to negative root 1/2, root 1/2 to infinity. Okay, so that is the increasing and decreasing. Now, because it's changing the direction of the derivative, so you will have a relative max and relative mean and relative max at the critical value. So this is going to be mean and max. So the relative and the problem will have because there's a changing of the sign of derivative, we have the mean and the max. So the local max occurred at x equal root 1/2, and the local mean is occurred at x equal negative root 1/2. Okay. Okay, now for part C. Part C is determine the concavity and point of inflection. For concavity, we will need the second derivative test. Okay, so we will take the second derivative. So we have the first derivative function that is simplified into here. You can use this one to find the second derivative, or you can go back to this one because these are the same. So you have the f prime of x right here is equal to negative 6 plus 3x squared. So since f prime is negative 6 plus 3x squared, I can write my f prime become negative 6 plus 3x to the power negative 2. And then I'm going to take the second derivative. My second derivative will be 0 because the derivative of negative 6 is 0. And then the derivative of 3x to the negative 2 will be 3 times negative 2x to the power negative 3. That gives you 6 over x cubed. Okay, so 6 over x cubed will be our F double prime. So the only critical value, the only possible inflection point that we can have is xq equals 0 because 6 cannot equal to 0. So xq equals 0, we will have x equals 0. And when x equals 0, we have two intervals, one on the left and one on the right of the 0. Now we do the side test for f double prime. So we will take x equal -1 and x equal positive 1. So -1 and positive 1. And put into f double prime of -1 is 6 over -1q, which is -6. So this is negative. And f of 1 obviously will give us the positive 6, and that will be plus. So it's going to be concave down when f double prime is negative, concave up when f double prime is positive. So 0 will not be the inflection point because on your function, the domain is x cannot equal to 0. So there's no inflection point. Okay, and you will have a concave of at the interval of concave up from 0 to infinity, and concave down is from -infinity to 0. Point of inflection does not exist. There are no point of inflection.